and a proxy-based approach. So I'll let you run with it.
Great. All right, thanks everyone. So full disclosure, I made way too many slides. So I'm gonna try to rip through the first half of this presentation really fast, and then the second half we can hopefully take more time. So yeah, I work at Development Seed. A lot of my work is with STAC APIs, and STAC APIs have seen a lot of great success in the past few years. It's now OGC supported standard, and we've liked to use STAC APIs because I think they're both flexible by virtue of the extension ecosystem that is available, but also has some convention that we can all agree upon, and there's interoperability amongst clients that use them. And yeah, it's generally well supported. A lot of clients are emerging, a lot of people are using them. And so let's talk about the state of authentication and authorization within STAC. By virtue of working at a consultancy, we see a lot of STAC APIs and a lot of different partners that have different needs. And we've seen different strategies for authenticating with STAC that are often, JWT. I'm not going to read these, but you get the sense. There's a variance in how do I tell a STAC API who I am, when am I making a request, and thereby, am allowed to see certain data. And it's kind of, choose your own adventure. There's not really a recommended way to do it. It's kind of left into the hands of the implementers to figure out what the right strategy is. STAC, as far as I'm aware, doesn't really have any best practices or suggestions around authentication and authorization. And so it seems like amongst the projects we've seen, there's 3 different classes of authentication authorization needs. Which are the route level auth, record level auth, and ACID level auth. And so those are the 3 classes of auth requirements that we're going to talk about in this presentation. And everything's really going to be centered around this tool that we built, the stac-auth-proxy, and kind of how this tool is being considered to solve those 3 classes of needs. So the backstory of this is just about almost 1 year exactly ago at SAT Summit Lisbon, there was a Birds of a Feather talk where we got together. It was like 5 people and just kind of riffed on some ideas of the solutions to like our common needs. And I came in hot with an idea that was not a proxy. I don't really like the idea of a proxy, but that's kind of where the conversation ended. It really seemed like everybody had their own needs, and a deep integration wasn't really possible because everyone had different backend tooling systems, right? And so, I just list these out. There's, Stack FastAPI PG Stack, which is commonly used by Development Seed, and that's written with Python and uses PostGIS. And then there's Stack FastAPI Elasticsearch and OpenSearch, which is Python and those backends. And we can keep going. There's GeoParquet and Stack Server with Elasticsearch, and there's just no shortage of tools. And we also accept and acknowledge that in the future, there are gonna be new backends, right? GeoParquet is kind of a thing that wasn't here a few years ago. And we have no idea what the next thing is gonna be and the next popular language. And that's okay. We're trying to think of a solution that could provide benefit to all those ecosystems without requiring a partner to alter the tooling that they use. And so, the strategy of the auth proxy is just to, at first right now, target the most common needs. Naturally, one solution isn't going to meet everybody's requirements, but we're going to aim for the largest sets we can, and then we're going to do so by embracing open standards. Again, speaking to the STAC ecosystem, there's a wealth of extensions that we can lean on and have expectation that backing STAC APIs are going to implement those extensions. And then minimize configuration by just kind of providing sensible defaults. And then ideally this tool is usable as a standalone service that you can run as an application or as a code base that you can customize and therefore be ultra expressive in how you want to apply auth solutions. So here's where we are today. We have this workflow. It's a little dense. But we have a client, it's going to authenticate with an OIDC server. That's kind of like this meet people, the majority of people. We ask that they have an OIDC compliance server. So that's auth0, that's AWS Cognito, that's Keycloak, some just modern auth server. That's kind of a hard requirement today, maybe in the future not, but right now it is. and they need to come with an access token, a JWT. And so they'll make a request to the stac-auth-proxy, and at that time we'll validate the token, and then augment the request, and then forward the request to the STAC API, and get the response, augment the response, and return it to the client. And so I should add this note that this doesn't have to be a proxy, right? Really, this tool is like 11 middleware classes in a trench code, and there's like one API handler that just forwards every request to the upstream. So you could theoretically just install this via pip, and then we have this method in here, or this function called configure app. And you have a FastAPI based app, or theoretically any ASCII compliant app. We haven't tested it with anything other than FastAPI, but theoretically, if your app speaks ASGI, it would work. And then you can pass it in here, and we'll wrap that app with our middleware and apply like these auth toolings to it, right? So, anyways, moving on. How would someone use this? I guess there's two pieces of configuration you really need. You need the upstream URL. Where does the STAC API live? You need to tell the auth proxy that. And then secondly, where's the OIDC discovery URL? So the OIDC is really nice, OpenID Connect, because part of the specification requires it to have this OIDC discovery URL, which is a document that points to keys that can be used to validate JWTs and what kind of auth flows it supports and so forth. And so that's really nice. So this is like the one piece that you need to give us, and now we understand enough about your auth server to integrate with it. And yeah, once that works, now we can impose things like route level auth. So route level auth is kind of like the most basic intro, or like the most basic need of, can I access this API endpoint, right? So common use cases are, private STAC APIs. I'm a company, I have a STAC API, it's on the internet, but I only want authenticated users to be able to access anything in it, search it, list collections, so forth. Or another common thing is, it's a public API, but we have the transactions extension available. So people are allowed to edit data, but only, of course, people who are authenticated and authorized, right? Usually staff or contributors. And so how do we do that with the stac-auth-proxy? There's a simple flag, default public is what we ask. By default, are all the endpoints on your API, are they public or private? That's like the main question we're asking. And going to the sensible default idea, if it's false, we're gonna assume if everything's not public, then there are some endpoints that probably should still be public. For example, the landing page that just tells you metadata about the STAC API, none of your data, what you're storing in it, but just what are the capabilities of it, that would be public. You can read through these. There are other endpoints that we don't see as dangerous to have as public, even if your STAC API is private. And then the inverse of that, if the STAC API by default is public, we're just going to assume that you want your transaction endpoints to be private, right? And the way you describe these is like a regex expression where you map, a path to an array of methods on which someone's operating. So yeah, this is private endpoint. This is like basically what is implied unless you override this with your own configuration. You can also, for the only exception of this is for things that are private, you can also add a second part to the array. So instead of being an array of methods, you can add an array of tuples, and the second part of the tuple is scopes that are embedded in your HTTP token, or pardon me, your JWT token that we're going to check for to make sure, you actually have this individual permission in your JWT. And so this is like a common pattern of you can have these really fine-grained scopes that some people are allowed to edit collections but not delete collections and so forth, right? And so we want to lean on some reuse. Oh, so I guess I should say, now that we know this about your STAC API, you've told us these are the endpoints that are private and these are the endpoints that are public. We can do things with that. Not just guard your API endpoints, but we can share that information with consumers and clients so that they can make the right decisions when making API calls to your STAC API. And so we do that via the authentication extension. So, the nice thing about STAC APIs is that they're self-descriptive. This landing document that kind of explain the capabilities of the API and links and the extensions that the STAC API would support. And so in that, we have these links that might have hrefs. And now by virtue of the fact that they have an href, we already have a map of what's private or what's public. And so we can run some logic, and if it's a private endpoint, we'll add this auth-refs and tell it, hey, you need to log in with OIDC to hit this link, right? And actually, I don't think a human's doing this. It's probably a client that's doing this logic. But nonetheless, yeah, so we can infer that decision. And then at the bottom of the document, we're going to insert this detail to say, hey, this is what the OIDC scheme is. And it's going to have that, that OIDC configuration URL that we talked about earlier involved in it, so that a client can go to that URL, figure out how to log in, come back, and now knows which API endpoints to be sending tokens with when I make a request. And let's see, what's next? And then I guess we insert this into the stack extensions. Say, hey, this API now is using the authentication extension because it's using the auth-proxy. And then we can keep going. Why just stop there? Even though this is not technically part of the STAC API, a lot of STAC APIs support the open API spec. And so we, again, have that information, right? So you need to tell us, the stac-auth-proxy, where the open API spec is served from. And if that's done, then we'll take an open API spec like this, and then add the security detail to it. Say, hey, you need OIDC auth to connect to this, to post to this collections endpoint. And this is an example of the Veda project. And so you'll see they've done this, and now you get this authorize button, which is really slick. And you can scroll up and here's that OIDC configuration endpoint again. And so what's happening is the Swagger UI, which is this client for OpenAPI, has gone and fetched this document when I loaded it, and now it knows all the scopes that are supported, and yeah, whatever. It just kind of works that way. And then, oops, I shouldn't have pressed that button. Then if I scroll down, these endpoints that are protected now have a little lock on them, right? So if I try to hit it, I can send a request, and I'll get a 403 ideally. Oh, well, you get the idea. Okay, let's keep cruising. So whatever. That, now we're basically augmenting the OpenAPI spec to get buy-in from clients that can consume it and give people kind of a fluid experience when interacting with the API. Let's keep moving. Record level auth. So this is probably a bit of a meatier topic on it, the stac-auth-proxy, and it's taking a lot more time, which is this idea of certain data sets should be available to certain people. Not just the endpoints themselves, but a subset of data, right? And so use cases, sometimes people want draft data. They want to stage a collection and start populating it, but it's not until that collection is actually ready that they mark it as public, and then now it's available to the world, right? So during that time, you might only want to keep it available to logged in users. And then maybe you have a sales model that you expose data via a subscription model. And then finally, this concept of multi-tenancy, right? What if we can serve multiple users and backends via one STAC API, which we'll jump into in a second. Okay, so the way that works is we ask people to generate CQL2 expressions based on request context, and then the stac-auth-proxy applies that CQL2 expression to the requests before they go to the upstream STAC API via the filters extension. So the flow looks like this. Maybe a client asks for collections. We're going to check the credentials, create a CQL2 filter, and if one has been generated for that user, we'll apply it to the request, and now you'll see this is kind of an augmented request that goes up to the STAC API. So we catch the request, augment it with whatever kind of auth-related logic we need, send it up to the STAC API, and then the STAC API sends back a response. And so the idea is that we don't need to really configure the STAC API to know anything about the user. At this point, we just need to treat it kind of like a database almost, with using CQL2 to filter it. And our expectation is any backend that supports the filters extension should be able to properly filter this data. And this is kind of in a hope of having a future-proof solution. But you might be asking, not every endpoint supports the filter extension, right? Which is true. And so there might also be a situation when you want to look up an individual record. And how would that work for an endpoint that doesn't support the filter extension? And it's pretty much the same. We're going to check the credentials, generate the CQL2 filter, but then we just send the API request to the STAC API, get the response, and we validate the response against the CQL2 filter. So after the fact that the STAC API has already responded, we don't know yet if we want to let the user see that response. And so we'll check it now against the CQL2 filter. There's a CQL2 RS library that allows you to take an expression and pass in an arbitrary JSON object or like Python dictionary, and it'll test true or false whether the filter would pass with that object. So yeah, that's how we do that. And so that's how we apply record level auth on like details endpoints that don't support the filters extension. So yeah, I don't know, this is how you configure it. It's a little funky. You gotta pass in a path of a module to where that filter factory is. So this is kind of what we ask the users to do. The implementers need to bring a class that's going to take in a request context and generate a CQL2 filter. And so you might need some arguments to it. And the same thing is true for items. You need a separate filter generator for the collections endpoints and for the items endpoints. And here's an example of one. Like here, actually, this is an example of how our code uses the filter builder. So like you would provide the filter builder, we pass in this like request and any scope that's stored in like the request state. And then we validate the CQL2 filter, make sure it's valid, and then apply it. And so here's an example of a filter factory. It's pretty simple. It's like a class, and once you initialize that class, it's a callable. And we call it with this context object, which is, again, everything we know about the request. Yeah, and if you don't like classes, you can do it with a function too. It doesn't really matter. The point is that there's an initialization step, which is like if you're connecting to the database or like an API, you might want to set up a connection pool like once per the life of the stac-auth-proxy to kind of get things warmed up. And then we call this example filter function with every request. Yeah, so there's some built-ins. Right now there's two. Jinja 2 templating, which is like kind of gruesome to write, but it's available. It's kind of good for like prototypes. The idea is that if your auth policies change, you probably don't want to redeploy your STAC API or your stac-auth-proxy, and I get that. So another alternative would be like open policy agent. And so second example will like make a call to open policy agent and pass it to this stack items allowed. I think it's called a decision object, and it'll cache the results in this example for 30 seconds. Yeah, and so we can talk about an example. We should talk about the NASA Veda project. I want to take a pause to say Veda is a project for open source visualization, exploration, and data analysis, which is really about data narration, creating stories around Earth data. It's created by the OIDC team at Marshall Space Flight Center. And I think, this is like, I feel like the OIDC team at Marshall is kind of a classic silent supporter of FOSS data or FOSS application software. And a lot of this work is made possible through them either directly contributing or funding projects like this. And so they've been using stac-auth-proxy, which is great. And they're using it for multi-tenancy, which is pretty funky. It's like not really the intended thing we're thinking about when we designed it, but it works for that, and that's great. So here's the flow. Like a request will come in, and what they've chosen to do is have a tenant stored in the path of a request. So they have one origin, one domain, because at NASA it's very difficult to get multiple domains. So instead they use the path itself. And so for example, this is a fire tenant. And what we'll do in the stac-auth-proxy, they have actually, in their code, they have a middleware to extract that tenant from the path. And so no longer is fire tenant in the path, it's now stored in the request scope as this tenant property. And then we take that and turn that into a CQL2 filter expression, for example this. And then finally, we append that to the path as it's going to go out, and then we let the STAC API process that. And so, of course, the downstream, or I guess you say upstream STAC API knows nothing about multi-tenancy. It has no concept of it, and it doesn't know that there used to be a fire tenant in the path. All it knows is getting data to be filtered for this fire tenant collection. And so yeah, and the way you associate a collection with a tenant is they just throw a property on the collection itself, which is possibly contentious. Some people would say metadata should only be about the sensors and how it's collected. I'll let you sort that out. There are other ways to do it, but that's the way they did it. And here's their filter generators, so CQL2 filter factories. So, it's pretty simple. You call it with a context, you get the tenant from this context object. And if there is a tenant, you throw this on the filter. Boom, keep going. Same with items. Items actually a little more complex because a challenge with CQL2 is that you can't traverse relationships, right? You can't filter items based on a property of the collection that they belong to. So by virtue of that, we call this, we get the tenant out of the request, and if a tenant is available, we actually fetch all the collections that are supported by this tenant in an API call, and then we build a CQL2 filter expression. Yeah, I'm gonna cruise through this. Here's a demo. I think you get the idea. It's just cool because this is running in my slide deck. I love that feature. Oh, but it's fetching and slow, so there you go. So you get like 6 when you're looking for certain tenants, right? And then maybe a different one, you'll get 4. So it just demonstrates like now multi-tenancy is a part of the STAC API by the methods I described. The final kind of auth flow is asset level. And I think this is kind of the holy grail. I think often people wave their hand and say, well, that's not the responsibility of the STAC API. That's the responsibility of the file server or wherever that's stored. But I would argue that there's value in coupling the logic that if you're allowed to see it, the metadata, you would be allowed to access the data, or vice versa, really, probably. And so that's kind of like the next level. We're not really there yet, fully described. But this is how it would theoretically work, is that the authentication extension supports signing of URLs. So for an asset, we would insert the same kind of signed URL prop, and then I'm going to rip through this really fast. In that signed URL kind of auth scheme, we would say, hey, here's the endpoint to go get a signed URL for this asset. Here are the parameters you'd provide, the collection ID, authN ID, asset key, and then get back a signed URL. And you'd have to be authenticated to do that. So we can kind of couple the logic of that. So that's what's next, asset level IDs. Record level auth for transactions endpoints aren't currently supported, but it's in the future, and then performance upgrades. And so that's the end of it. We'd love to hear feedback. Like, this is like a 1-year-old project, very fresh, still just warm out of the oven. And so there are certainly design decisions that should be challenged and can be challenged. And really what we want to do is put it in people's hands, get critique, give me your angriest issue on GitHub. That's okay. Thank you.
Any questions for him? Please first.
I have a question. I just noticed it would be great if at the route level you'd be able to use placeholders in the regular expression. That will solve lots of problems. For example, authorizing users to access a specific collection. For example, having their username inside, or other combinations like this.
Yeah, just to fill it in, you're describing putting an auth logic into the regular expressions when we say if an endpoint is public or private. Is that kind of the suggestion? No.
No, just to be able to expose some of the properties from the context. I think that was the name, the context.
Yeah.
To expose it in the regex. So, for example, to expand the variable with sub, for example, meaning the user or...
Well, to be honest, we do actually do that, and I actually don't. I'm regretting that decision. But I don't want to say we do parse the regular expressions and pass in the collection ID as like a separate property, I think, as this request. I actually think it's probably just better to send the entire request to the into the callable and let that factory figure out how it wants to parse it. So I get the intention. I had that exact same thought, and I think we're kind of there, but I don't know how long. But anyways.
Yeah, I have had mixed experience with Stack backends supporting SQL filtering. Not all of them are made equal or do the right thing. So what would you recommend as a good compliant SQL happy thing?
Yeah, well, what I can tell you is that we have the expectation that if a Stack API advertises that it supports the filters extension, we have that expectation that it works, right? And so if it's not, you should make a pull request or a issue to back-end tooling. But what we do also do is that if you opt into like the filter logic for record level auth, we check the conformance of the API when the stac-auth-proxy boots. And we will throw an error if your stack API does not advertise supporting the filters extension. You can opt out of that. Like if you're running this in like AWS Lambda, you probably don't want to do that auth check every single time the request is processed. So you can turn it off, but right now we want it to be explicitly like failed if the stack API doesn't advertise that feature. I think there's one
Any
more.
more questions?
First off, we recently added the asset proxy pre-signed URLs to Stack Server, so we should chat about how we did that because there might be something to share there. You mentioned that you were against the proxy in the beginning, and I shared similar feelings, though I'm coming around. So after working on this, do you still feel that same way? And can you maybe describe in a summary what your original idea was and how it compares to this?
Well, yeah, I mean, so the summation of my ideas is that it's the least worst solution, but it's like not great, but you know, like I don't want people to be forking Stack FastAPI PG Stack and embedding their deep logic into like the query like portions, right? That's difficult to do and hard to maintain. So I think this is slightly better. I don't like for me, I don't really work in the Kubernetes world. So if, like slapping on chaining processes to process a request is awkward and weird for me. It seems like Kubernetes people are actually very comfortable with that and they're doing it. So I don't know. That seems apparently to be a non-issue. So I don't know. It's not my ideal scenario, but yeah. And then I guess when we learned or figured out that we can just run this as middleware rather and in the same process, because a lot of these people are using lambdas to run these stack APIs, and so chaining lambdas, one being for the stac-auth-proxy and one being for the stack API, feels like an anti-pattern. It feels like a bad idea. And so now that we realize, oh, we can just actually put them in the same process, the same lambda, I'm sleeping better at night. So yeah.
I think we're running out of time for questions, but I'm sure Anthony's going to be floating around later this afternoon at afternoon tea.